Okay, in this video we're going to be looking at the 5-number summary, which is an important data summary for a list of numerical data. It provides key information about the centre and the spread of any data set, and the 5 numbers are also integral to the construction of a box plot, which we'll look at in the next video. So they're the 5 key points that we need to work out for the box plot. So the 5 numbers that comprise the summary are the minimum value, easy, the lower quartile, the median, the upper quartile, and the maximum value. Okay, so minimum and maximum are easy. Do those first, or think about those first, and then discard them. I don't mean get rid of them from the data set, but you then need to kind of get rid of them. The other 3 values, lower quartile, median, and upper quartile, are about dividing the data into 4 equal groups. Okay, the median is the middle of the data set. The middle point of the data, the middle value, if you've got all the data, it must be in order from smallest to largest. The value that sits in the middle is the median. If you have an even number of pieces of data, there won't be a number in the middle. Okay, so say for example, when we have an odd number of bits of data, so if we have 5 bits of data, they're in order, there is a middle piece of data. The third piece is the middle. Okay. If we have an even number of pieces of data, there isn't a middle. The middle is between the third and the fourth piece of data, the 3.5 piece of data, if you like. And there's a formula we can use, and I've got it written here, for working out which piece of data will be the middle. Okay, we add 1 to the total number of pieces of data and then divide by 2. So here, where we have 5 pieces of data, the middle value is the 5 plus 1 over 2th piece of data. So 6 on 2, which is 3. It's the third value. Okay. Here, where we've got 6 bits of data, the middle value is the 3.5 value. Okay, so that's telling you that it's between the third and the fourth. And when it's between the third and the fourth, we take the third and the fourth and we average them, which means that we add them together and we divide by 2. Okay, and that becomes your median value. So you need to work out min-max, think about those, forget about them. Then you need to work out your median, where is the middle? And then you need to work out your quartiles. So we've divided the data into 2 by finding the median, and now what we need to do is divide it further into 4. So we essentially then take each half of the data either side of the median. So when the median is a data value, we then exclude it, and we then look at the first half of the data and find halfway there, which will be there, and halfway in the second half of the data. So Q1, the first quartile or the lower quartile, will be here. The median is that value, and Q3 will be that value. Okay. When we've got our 6 pieces of data, the median's not an actual data value. So there's 3 bits of data in the first half. That will be Q1. This one up here will be Q3. So Q1 is here, Q3 is here, and the median is here. What you should find is when you've divided your data using your quartiles, you should have the same number of pieces of data before, from the minimum to before the, so we've got 1 bit of data before the lower quartile, between the lower quartile and the median, there's 1 bit of data, between the median and the upper quartile, there's 1 bit of data, above the upper quartile, there's 1 bit of data. So we have divided the data into 4 equally sized groups. Okay. Again here, 1 bit of data before Q1, 1 bit of data between Q1 and the median, 1 bit of data between the median and Q3, 1 bit of data. Okay. Obviously we have much bigger data sets, and we'll have, 5, 6, 20 bits of data between, in each of those groups. But essentially you should have however many bits of data, X bits of data, then Q1, another X bits of data, then the median, another X bits of data, then Q3, and another X bits of data. Now Q3 might be an actual value, that's okay, or it might be between 2 values, but it's really important that essentially what we're doing is dividing the data into those 4 equal groups. Quartiles, we're quartering the data. Okay, so the lower quartile represents what we call the 25th percentile, and that's the value where 25% of the data is smaller than it and 75% of the data is larger than it. The median can also be called the 50th percentile, and that means that 50% of the data is smaller than that value and 50% of the data is larger than that value. Upper quartile is the 75th percentile. 75% of the data is smaller than it, 25% of the data is bigger than it. Okay? Alright, from these 5 numbers we also calculate 2 measures of spread. One is the range, which we've talked about already. The range is the maximum value minus the minimum value. And then there's also the interquartile range, because the range can be skewed by outliers. If you've got one strange outlier, your data can look like it has a huge range. Whereas if we look at the interquartile range, which is the upper quartile minus the lower quartile, we're just looking at how spread out the middle 50% is. So those two things in conjunction can tell us different things. If you've got a data with a range of 100, but the interquartile range is only 10, it's probably suggesting that there's an outlier. 50% of the middle 50% of the data lies within a range span of 10 numbers, whereas, you know, the whole range of the whole data set lies within a span of 100 numbers. So it's suggesting the data is pretty closely grouped together, but there is just, you know, potentially some outliers. Okay, so here's another example similar to what I was just demonstrating with the dots. So let's say we've got this data set. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. So min and max, I find those, okay? That's easy. But then don't disregard them. They need to still be part of the data set. Sometimes people sort of get confused and think, oh, I've got to have 2 values between the minimum and Q1, and then, oh, hang on, I've got 3, I haven't done it right. But no, min and max, so we've got 3 values, then Q1, 3 values, then the median, 3 values, then Q3, 3 values. So we have divided the data into quartiles. To find the median here, what did I say? There's 15 pieces of data. So 15 plus 1, divide that by 2. It's 16 divided by 2. So the 8th piece of data is where the median is. The median isn't 8, the median is the 8th piece of data. So in your data list, you know, 1, 2, 3, 4, 5, 6, 7, 8. So there's the median. Then once I've identified my median, and the median is a data value, we're essentially kind of ignoring that, and we're looking at the first half of the data. There's 1, 2, 3, 4, 5, 6, 7 bits of data here. Now, when you're finding halfway, you're essentially using the median. You're essentially finding the median of the first half of the data to find the quartile, the lower quartile. So we've got 7 bits of data. Add 1 to it, divided by 2. That's 8 divided by 2. So the 4th bit of data will be Q1. Okay, 1, 2, 3, 4. There's Q1 there. And then in the second half, you can use the same pattern in that it'll be the 4th bit of data in the second half. So 1, 2, 3, 4th bit of data in the second half will be Q3. And again, once you've identified those values, you should be able to then look at, okay, before Q1, there's 3 data values. Between Q1 and the median, there's 3. Between the median and Q3, there's 3. And after Q3, there's also 3. So I've correctly divided the data into quartiles. Okay, so let's work through some examples then. Identify the 5-number summary and calculate the range and the interquartile range for each of the following data sets. Okay, start with the minimum and max. That's easy. They're already in order. If they're not in order, that's your first step. You must order the data. So minimum value is 3, maximum value is 14. Okay, then we want to think about our median. So how many bits of data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 bits of data. Add 1 to it, divide it by 2, gives us the 6th piece of data is the median. Okay, 1, 2, 3, 4, 5, 6. So that's the median, 8. Then I can just focus on the first half of the data. Now, because it's a relatively small set, I can see by eye that that's the middle of the first half. But you've got 5 bits of data, add 1 to 5, and then divide by 2. That gives you the 3rd bit of data is Q1. So there's Q1, 1, 2, 3. And then in the second half, it'll be the 3rd piece of data in the second half, 1, 2, 3. That piece of data will be Q3. Okay, so Q1 is 6, Q3 is 11. Again, you should be able to check. You've got 2 bits of data, then Q1, 2 bits of data, then the median, 2 bits of data, then Q3, 2 bits of data. All right, the range is max minus min, so 14 minus 3, so the range is 11. And the interquartile range, or IQR, is the upper quartile, Q3, minus the lower quartile, Q1, so 11 minus 6, which is 5. So the data spans a range of 11 values. The middle 50% of the data spans a range of only 5 values. Okay, next data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bits of data. Median will be add 1 and divide by 2, the 7th piece of data. Let's write in our min and our max. 1, 6, 1 and 2, 3, 6. The data's in order. It says up here all data, all have been ordered. But as I said, if that step's missing, first thing you need to do is order the data. Okay, so with the 7th bit of data is the median. 1, 2, 3, 4, 5, 6. Oh, let's count. 1, 2, 3, 4, 5, 6, 7. So there's your median. Okay, so then in the first half of the data, I have 6 pieces of data. So the middle, when I have 6 pieces of data, add 1 and divide by 2. So that's 7 divided by 2. That's 3.5. Okay, so that means it's going to be between the 3rd and the 4th value. So that's going to be Q1 there. So to actually find Q1, we need to average the values either side of that. So we do 173 plus 182 divided by 2. Now, if the numbers are, 173 and 174, then you can probably know that between 173 and 174, it's 173.5. So you might be able to average them or work out the halfway value really easily in your head. If the numbers are 6 and 8, halfway between that is 7. Okay, but to calculate it, if it's not so easy, add them together, divide them by 2. That will always work out the halfway value. So let's just do that. I've got it on my CAS over here. 173 plus 182, dividing that by 2, Control Enter. So it's 177.5. Okay. And then in the second half, it'll be the same logic. We've got 6 pieces of data in the second half. So between the 3rd and the 4th piece of data in the second half will be Q3. So again, we're going to need to average. Q3 will be 214 plus 222 divided by 2. Again, if you can work that out in your head, not so much adding and dividing by 2, but where's halfway between 214 and 222, that's absolutely fine. Many of you will have been able to do that and say, well, from 14 to 22, that's 6 values, and, sorry, it's not 6, 8 values, so halfway between, I just need to add 4 on to 214. But if you can't do that and don't see that, that's fine. So 218 and our median was 199. Range is max minus min, so 236 minus 161. 236 minus 161, which is 75. And interquartile range is 218 minus 177.5. 218 minus 177.5, which is 40.5. Okay, part C. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits of data. Minimum is 11, maximum is 30. 10 bits of data, add 1 and divide by 2, so 5.5. So the median is between the 5th and the 6th values. So 1, 2, 3, 4, 5. So it's going to be there, the median. So you want to average 18 and 22. I know that the middle of 18 and 22 is 20, okay? But if not, add them together, divide them by 2. Again, it's going to 18 plus 22 is 40, and 40 divided by 2 is 20. You'll get your CAS to do it, and you work out your median. Okay, now in the first half of the data, I've got 5 pieces of data, which means there will be a middle to that. 5 plus 1 divided by 2, the middle is going to be the 3rd piece of data in the first half. So that's going to be Q1, 15. And then same logic here, 5 bits of data here. The 3rd of those 5 bits of data is going to be Q3. Range, 30 minus 11, which is 19. Interquartile range, 25 minus 15, which is 10. Again, should be able to check. 2 bits of data, then Q1. 2 bits of data, then the median. 2 bits of data, then Q3. 2 bits of data. Same up here, we didn't verify that, but 3 bits of data, then Q1. 3 bits of data, then the median. 3 bits of data, then Q3, 3 bits of data. Okay, final example here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bits of data. Minimum is 35, maximum is 71. Median will be 12 plus 1 divided by 2. 13 divided by 2, that's the 6.5th piece of data, which there isn't, so it's between the 6th and the 7th. Oh, my apologies. Between the 6th and the 7th. So 1, 2, 3, 4, 5, 6. So here it's going to be your median between 49 and 52. Again, if you can work that out in your head, absolutely fine. If not, 49 plus 52 divided by 2, control enter, 50 and a half is is the middle of 49 and 52. Many of you will be able to do that without your CAS, and that's fine. Alright, then looking at the first half of the data, you have 6 pieces of data there. The middle of 6 pieces of data is going to be 7 divided by 2, 3 and a half, so between the 3rd and the 4th, so Q1, and then between, again, looking just at the second half, between the 3rd and the 4th of the second half is going to be Q3. So halfway between 41 and 45, again, if you can do it in your head, great. If you can't, get your CAS to help you. 43, halfway between 58 and 62. Hopefully most of us can work out that that's 60. If not, do it with your CAS. Okay. Again, 3 bits of data, then Q1, 3 bits of data, then the median, 3 bits of data, then Q3, 3 bits of data. So we've got all sorts of examples here. In the first example, the quartiles were all actual data values. In the second example, the median was a data value, and then Q1 and Q3 were between data values. In example part C, the median is between 2 values, but Q1 and Q3, and Q3 are actual data values. And in the fourth example, none of the quartile values. The median's also a quartile. It's the, second quartile. The quartiles are all, none of them are data values. Okay, so all of those are the 4 combinations of things that can happen. Doesn't matter. It all still works in the same way. Let's just work out our range and interquartile range. So 71 minus 35 here, so that's 36. Use your CAS if you need. Interquartile range 60 minus 43, so that's going to be 17. Alright, so then we need to be able to identify the 5-figure summary from a plot, various plots. Okay, we want to identify the 5-number summary and calculate the range and interquartile range for each of the following data sets. So what you need to be able to think about is that your, in this case, stem plot is just a list of data. If we were to list it out, in this case we've got our key, it's 101, so it would be 101 and then 102 and then 115 and then 118 and then 122 and 123 and 123, etc., all the way up to this last data value, which is 157. Okay, so we don't need to list it out. We need to be able to think about it as a list though. So if we count up the leaves, that's going to tell us how many bits of data we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pieces of data. Okay, so we've got 17 pieces of data. Sometimes when we talk about the number of bits of data, we say n equals 17. Your CAS uses n. I'll show you that in a minute. We'll look at how we get the CAS to calculate some statistics, including these 5-number summaries. So n equals 17, which means that the median value is the 17 plus 1 divided by 2, so that's 18 divided by 2, which is the 9th value. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the median there, 136. Alright, then before that, we now have, looking at the first half of the data, there's 1, 2, 3, 4, 5, 6, 7, 8 bits of data before the median. Halfway between the, so if we've got 8 bits of data, the middle of that will be 8 plus 1 divided by 2, which is 9 on 2, or 4.5. Okay, so it's going to be between the 4th and the 5th. So 1, 2, 3, 4. So the 4th value is 118, and the 5th value is 122. Okay, so we've got our median we know is 136. Q1 is 118 plus 122 divided by 2. Halfway between 118 and 122 is 120. And then Q3, second half of the data, we have 1, 2, 3, 4, 5, 6, 7, 8. And again, we're looking for between the 4th and 5th. So 1, 2, 3, 4 is 144. Q3. And then the 5th value is 155. Okay, if you can work that out, that's fine. It is going to be a decimal, so I'm just going to check it with my CAS. 149.5 for Q3. And then obviously we've got our minimum and our maximum. I've listed them a bit randomly here, but that's okay. Should have given us some more space. Minimum is 101, and the maximum is 157. Oh, and we also need range and interquartile range, I think. Question specifies. Yep. So range is going to be 157, which is the max, minus 101, which is the min. So that's going to be 56. And the interquartile range, Q3, which is 149.5 minus 120, which is 29.5. Okay. Alright, I'm not going to try to not write so much of this out this time. Alright, so here we have counting the dots to work out how many bits of data. Again, if we were to list this data out, we've got 2 zeros, 3 ones, 4 twos, 5 threes, etc. Okay, up to 1 5. So thinking about it just as a list of data, it's ordered when it's in a plot, so that's an advantage. You don't need to order it yourself. Counting the dots to see how many bits of data I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so n equals 18 here. So that means the median is the 18 plus 1 over 2, which is 19 on 2, so it's 9.5th value. Okay, so between the 9th and the 10th. So let's list out. We've got the minimum we know is 0, and the maximum is 5, which means that the range is 5 minus 0, which is 5. Okay. We've worked out that our median is the 9.5th value, so between the 9th and the 10th, so we're going to need to calculate that. So 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5, 6, 7, 8. 9th value is a 2, and the 10th value is a 3. So halfway between 2 and 3 is 2.5. Alright, so that means that the median's literally there. So you've got 9 bits of data before that and 9 bits of data after that. So the middle of 9 bits of data, 9 plus 1 is 10, divided by 2 is 5, is the 5th bit of data. Okay, so again if we count 1, 2, 3, 4, 5, the 5th bit of data is a 1. So Q1 is a 1. And in the second half, it will also be the 5th bit of data, 1, 2, 3, 4, 5, and the 5th bit of data is a 3. Alright, and so therefore we've calculated our min, max, range, our quartiles, so we just need our interquartile range, which is Q3 minus Q1, which is 2. Okay, here we have a bar chart. So again, it's about thinking about this as a list of numbers. So the bar chart here is showing me that if I list out the numbers, I'm going to have 2 12s, and then 7 13s, etc., all the way up to 120 at the end. Okay. So thinking about, in terms of how many bits of data have I got, well there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I think I lost count then. What is it? 2 plus 7 is 9 plus, 15, sorry, I'm right. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 30 bits of data here. Okay. So our minimum value is clearly 12. Our maximum value is clearly 20, which means that our range is 20 minus 12, which is 8. Okay. Then if we've got n equals 30, the median is 30 plus 1 divided by 2, 31 divided by 2, 15.5th piece of value data, so somewhere between, halfway between 15 and 16. Okay, so again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So that means our median is 14 plus 15 divided by 2, halfway between 14 and 15, which is 14 and a half. Okay, so the median isn't a data value, the median's sitting bang in between there, which means that we've got 15 bits of data in the first half and 15 bits of data in the second half. If you've got 15 bits of data, adding 1 and dividing by 2 tells you the 8th piece of data is the middle piece of data. 1, 2, 3, 4, 5, 6, 7, 8. That's Q1 there, which is a 13. And then again the 8th bit of data, but in the second half, so 1, 2, 3, 4, 5, 6, 7, 8, that there, which is a 16. So Q3 is 16. And then the interquartile range is 16 minus 13, which is 3. Alright, so again, you should be able to check that you're going to have 1, 2, 3, 4, 5, 6, 7 bits of data before Q1, 1, 2, 3, 4, 5, 6, 7 bits of data between Q1 and the median, 1, 2, 3, 4, 5, 6, 7 bits of data between the median and Q3, 1, 2, 3, 4, 5, 6, 7 bits of data at the end. Okay, so don't need to write out the list to do it, should be able to do it from the plot. Okay, part D, here we've got the data in a frequency table. The number of fish caught by 30 anglers in a fishing competition are given in the frequency table. Okay, so we need to understand what a frequency table means. This column of the frequency table means that there were 4 fishermen, 4 anglers, who caught 0 fish. So if we were to draw out the list of data, it'd be 1, 2, 3, 4 zeros. Then there were a further 7 anglers or fishermen who caught 1 fish. So it'd be 1, 2, 3, 4, 5, 6, 7. Then there were a further 4 fishermen who caught 2 fish, 6 who caught 3 fish, 4, 5, 6, 5 who caught 4 fish, 3 who caught 5 fish, and 7 who caught 1 fish. Sorry, 1 who caught 7 fish. My apologies. So, by all means, write out the list of data. Okay. However, you shouldn't need to do that, and if the numbers were bigger, that wouldn't be possible. First thing we want to work out is the total frequency, which is going to give us n. Okay, so 4 plus 7 is 11, 15, 21, 26, 29, 30. So n is 30. Okay, so we had n is 30 in the previous example. We therefore know that it's between the 15th and 16th value that the median lies. Okay, so we can, if we've got the list, we can count that obviously, you know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's your median there. However, we should be able to do it by gradually adding up the frequency. Okay, so if we add up 4, if we cumulatively add it up, then 4 plus 7 is 11, plus another 4, that's 15. Okay, so that tells us that the 15th piece of data is a 2. Okay. And that means that the 16th piece of data is a 3. So halfway between 2 and 3. Hang on, I've got my data wrong here. I haven't got enough 2's in my list. This is the problem. There should have been another 2 2's there, because there's 4 2's. So therefore, the 15th piece of data is indeed this 2. The 16th piece of data is this 3, and so the median is at 2.5. So adding up the data, we can see that there are 15 pieces of data, there are 4 zeros, and then 11 ones, and then another 4 2's, and so the 15th piece of data is a 2, which means the 16th piece of data is in the next group, which is a 3, and so the median is between 2 and 3. Okay. I'm going to get rid of my list because we want to be able to do it from the frequency table. We've already practiced doing it from a list. If you need to write it out, you can do it from the list. Okay, so we now know that our median is going to be there. Okay, so let me just write out what we're doing here. Median is the 30 plus 1 over 2, which is the 15.5th value, which means that the median is, the 15th values are 2, the 16th values are 3, so the median is 2.5. Okay, so then Q1 is going to be, that means that we've got, if the median is the 15.5, between 15 and 16, there's 15 values before the median. So again, 15 plus 1 divided by 2, that's 16 on 2, which is 8th value is Q1. Okay, so adding up cumulatively, okay, the first 4 values are 0, the next 7 values are 1s, okay, which means that the 8th value lies in this group here, which means it's a 1. Okay, and then again, we want the 8th value after the median. Okay, so there are, again, if we add up cumulatively just from the median, so the first 6 values after the median will be 3s, the next 5 values, so a total of 11 values, will be 4s. So that means the 8th value after the median is going to sit in that category. So Q3 is going to be a 4. Interquartile range, therefore, is 4 minus 1, which is 3. Let's also do our minimum, which is clearly going to be 0. The smallest number of fish you can catch is 0. The biggest is 7. Not the smallest number you can catch, but the smallest that were caught in this competition. And so then the range is 7 minus 0, which is 7. Okay. Alright, example 3. The last example, and then we'll have a quick look at how to calculate the stats with the CAS. So explain why the 5-number summary cannot be obtained from a histogram displaying grouped data, such as the one below. Okay, so the problem here is we can work out how many pieces of data there were. We can work out the total frequency. There's 2 here and 3 here and 6 here and 5 and 3. So if we add that up, we get 19 pieces of data. So n equals 19. So we could work out, for example, even as simple as if we were trying to work out the minimum and the maximum value. We can't be sure that the minimum is 15. We can't be sure that the maximum is 40. We just know that the minimum lies somewhere between, is bigger than or equal to 15 but less than 20. And we just know that the maximum is bigger than or equal to 35 but less than 40. Similarly, we could work out that the median, and we did this previously when we were looking at histograms, is the 10th value. And we can work out, okay, there's 2 values there and there's 3 values there and then there's 6 values here. So there's 11 values back there and only 5 values back there. So the 10th one must be in there. The median must be in that group. But we don't know what value it is. We just know it's somewhere between 25 and 30. And so we can't list the 5-number summary. Okay, so we can establish in which interval each of the 5-number summary lies. But we cannot pinpoint the values, pinpoint a particular value. For example, the median is the 10th data value which lies in the interval 25 to 30. Now that interval doesn't actually include 30, but that's about us all having a common understanding. It includes everything up to 29.999999. For example, the median is the 10th data value, which lies in the interval 25 to 30. but we cannot state the median value, the precise median value. Okay, just to finish off, let's have a look at how we find the 5-number summary with the CAS. So we're going to again create a new document. Now I've only got a calculator page here, so I could probably just insert a lists and spreadsheets page. But always a good habit to just regularly create new documents. No, I don't want to save my unsaved document. And then I want a lists and spreadsheets page, which is 4. We're going to name column A. Just going to call it data. And I'm going to enter the data in column A. Let's just pick one of these so we can confirm one of our answers here. So let's just take these numbers in part D. Question example 1, part D. So 35, 39, 41, oops, sorry, 41, 45, 49, 49, 52, 55, 58, 62, 70, and 71. Oops. Okay, so 12 bits of data. Yes, that's what we found back then. Okay, so once the data's entered, let's go back to the instructions. So you enter your list. Then we're going to press Menu, 4 for statistics, 1 for stat calculations, statistical calculations, and 1 for one variable statistics. We only have one variable. We only have one column of data. Okay, the number of lists is 1. And then we want to specify our list. Now, if we've named our list, if I press the right arrow, so let me just do that again. So you see, if you press the right arrow, it'll open up the drop-down box, and any variable I've got defined should be there. In this case, you see the default was to actually just list A with the square brackets, and that's referring to column A in the spreadsheet. So actually, if we hadn't named our column, we would have been fine. But I just think it's a really good habit for things down the track to name your data columns. Okay, we don't need to do anything else here except choose where our data is. You can edit if you want where it will put the results. This is telling me it's going to put the results in column B. If I wanted them to go into a different column, fine, but I can change that, but if not, no problem. Okay, so here is our one variable statistics, and we've got more than we need here. So the first row, X bar, that's the mean. It's added up all the data and divided by the total number of bits of data, which was 12. The second one, this symbol here means the sum of X. So it's the sum of all the data values. So that's just added them all up, 626. The second one here is the sum of all the squared data. We've squared all the data values and then added them up. We don't have any need for that, but that's useful in some other statistical calculations, so it might be handy for people to find that. The next two are important. The next two are both about the standard deviation. We'll talk about the standard deviation in a couple of videos' time. But in Further Maths, we only deal with the SX standard deviation. If you do Maths Methods, you'd be looking at the sigma X, which is the one in row 6 of the spreadsheet, but we would be using SX in Further Maths. We'll talk about that down the track. Then after that, we get into our 5-number summary information. N is the number of bits of data. There's 12 bits of data. And then here we've got min X, the minimum of the X values, the minimum of the data values, which is 35. Q1 is 43, median is 50.5, Q3 is 60, and the maximum is 71. Let's check that that matches our answers. We had, oh sorry, that's not it. Where's the data value? Up here. Min was 35, Q1 43, 50.5, 60, and 71. Perfect. All right, if we scroll a bit further here, we don't get, there's nothing else of use there to us. Okay, so we will be using mean and standard deviation later on, so helpful to know that that's the quickest way to get them, particularly standard deviation. It's the only way we can find that. Okay, so the work today is from 2B and 2C, looking at calculating the 5-number summary, either from a list of data or from an assortment of plots.